Recording. Today is the 20th of September. Okay, we're going to start with a few factoring problems just to warm up. I know we did one for our warm up here. Let's try a couple more. How about x squared minus 121? So do you guys remember you've got your different factoring? When do I do what? This looks like it is two terms. Are they both perfect squares? Is there a subtraction sign in between? Your phone should be down, ladies and gentlemen. You should be writing this down. You can do it in your notebook. If you can't find your notebook, do it on a piece of paper. That's fine. But you should be writing this down, and you should not be on your phones currently. Okay. Is x squared a perfect square? Yeah, right? Yeah. 121, is that a perfect square? Yeah. Yeah. So, and if there's a subtraction sign in between, then we should have x minus 11 and x plus 11. Okay? I should not be able to hear music because your music should be off while I'm giving instruction. You can turn it back on when you're working on individual work, but your music should be off right now so you can just focus on this. 2, I can walk around and take phones if you cannot turn your music off while I'm teaching. I can hear somebody across the room with their music on right now. So it's obviously loud enough for me to hear. Okay, number 2. How about we look at x squared plus 7x plus 12. Okay, this has 3 terms. So I know the first thing I'm going to have to do is look at, can I factor it? Okay, I'm looking at this factoring. I know x squared goes here, 12 goes here. There's no greatest common factor to pull out. There's no big number. So I know that x and x makes x squared, so I've got that part. What numbers multiply to give us 12 that add together to give us 7? 3 and 4. Yep. They both are positive. 4x and 3x does make 7x. So we get x plus 4 and x plus 3. Let's try another one, but you guys try this one on your own. Try this one on your own. So you guys are going to try x squared plus 10x plus 21. I'm going to give you a minute. Try that one on your own.
That's how you got to do it? I got the 2 numbers.
Okay. Give everybody else a second, and then we will do it. You don't.
Okay.
You don't. It's just a way to figure it out. Okay, so I like the Punnett square, but as Jordan said, you do not have to use this if you do not want to. So what do we got, guys? What are my 2 numbers?
73.
X plus 7 and x plus 3, right? Because 7 plus 3 gives me 10, but 7 times 3 gives me 21. Okay, let's look at this. What if I have, let's say 20 x squared y minus 28 xy squared. How many numbers do I have? Are either of them a perfect square? No. So now I know I can't use that one. Is there a number that I can take out of 20 and 28? What's the biggest number I can take out of 20 and 28? Because I know 2 will go in there, right? Is there a bigger number than 2? 4. So let's pull out a 4. What other letters do they have in common? They both have at least one X and at least one Y. So I'm going to take out an XY. Okay. So what's left over? 4xy times what gives me 20x squared y? 4 times what gives me 20? 5. 5x, good. Now I have to have a negative, correct? Because I need it to be a minus sign here and there's not one here. 4 times what gives me 28? 7. And 4xy, I need it to be 28xy squared. So I need it to be negative 7y. Okay? You guys want to try another one like that?
Yeah.
Okay. How about 15 squared minus... Okay, how about you guys try 5 on your own? Try 5 on your own real quick. Excuse me. Thank you. Sure. What do I do first?
I look at the equation I usually do. That 3 is going to be the highest number that can go at 15.
Okay, so I'm going to pull out a 3. What else am I going to pull out?
5 out of 15.
Hold on. What other numbers, what other letters can I pull out?
You can pull out an X, right?
And
Y.
okay.
Yeah.
So 3xy times what gives me 15xy squared? 5 what?
5.
Y.
Oh, Y?
Right, because it's y squared.
Oh,
3 times what gives me
11.
33. Good.
No.
11x. There we go. Okay. You guys feel good about some factoring? Do you think we need practice like this about every day? Yeah, some of this factoring. I don't know about you guys, but you know, if I'm not using this factoring every day, I don't remember it. And it's not something, like, I know you guys do math all summer long. You do, because you make change at your job, or you go somewhere and you figure out how much stuff is going to cost. But I don't think you guys do much factoring over the summer. Yeah.
I don't do much math.
Okay. All right. Okay. So now we're going to start, guys, with some multiplication. But I want to show you something before we multiply expressions. So we're going to multiply 5/10 and 20/15. But the first thing I want you guys to see right here is that you can cross-reduce. So we're not cross-multiplying, we're cross-reducing. So 5 goes into 5 how many times?
1.
But how many times does 5 go into 15? 3. How many times does 10 go into 20? 2. And 10 goes into 10 how many times?
1.
Once. So 1 times 2 is 2. 1 times 3 is 3. Okay, so that was cross-reducing, but I want to prove a point. What's 5 times 20? 100. What's 10 times 15? 150. Okay? So, what goes into both 150 evenly? What goes into 150 evenly? We're going to reduce it. 50. 50 goes into 100 how many times? 50 goes into 150 how many times? You can do these either way. You see how that works? One, you guys got to stop talking while I'm teaching. It won't be much longer, I promise. I'll give you time to work on your homework in class, but if it's going to be less and less the more you interrupt me. Okay, put your phones down. All right. So, one way, we call it cross-reducing. And the other way is just simple reducing. Either way, you get the same answer. I like cross-reducing because I feel like the bigger the numbers get, the less I'm good at finding the biggest number that goes into both of them, right? So I like cross-reducing. You can use either way. All right, now I need you guys to get out this worksheet in front of you so we can do some practice problems. Okay. Okay. We're looking right here at multiplying rational expressions. So we're just going to do some practice problems from this, and then we're going to use the same worksheet tomorrow and do some more practice problems for it. Okay? So you guys need to have this for today and tomorrow. Okay. We're going to look right at number 1. So the first thing I'm looking at is 59 and 33 and 99 and 80. I can't think of a number that I can reduce those by very easily. So I'm just going to go ahead and multiply. 59n times 80 is 4,720n. And 99 times 33 is 3,267n. Okay. Wait, what do they both have in common? The top and bottom have what? N, so we can cancel those out. Okay. This bottom one ends in a 7 and the top ends in a 0. Probably means there's no number that they can both go into evenly. Okay. All right. Why don't we look at the next one? All right, 51 and 93, I can't think of something that goes into then. 21 and 34, can't think of anything that goes into both of them evenly. But I do see an n on each side here, so I'm going to cancel those out. 93 times 34 is 3,162. 21 times 51 gives me 1,071, and I've got 21 times 51 n. Okay, they are both able to reduce by 51 goes in them evenly. So I have 62 over 21 n. 51 goes into both of them evenly. Okay. So that's just the simple way to do it. You multiply straight across, make sure you've reduced them. Let's look at number 4. Number 4, the first thing I noticed is that 25 and 85 both should be able to be reduced by 5s. Yep. So 5 goes into 25 5 times, 5 goes into 85 17 times. Now I've got 79 and 27. I don't think 9 goes into, I don't think it works. But I do see that one of them has an n and the other one has n squared. So I'm just going to change the bottom to n. Now I'm going to go 79 times 17 gives me 1,343. And 5 times 27 gives me 135N. Okay? We feeling okay about this? Yeah? All right, let's do something a little bit harder. Let's look at number 7. Okay. We're looking at number 7. The first thing I notice is this has 6R plus 2, and this over here has 6R plus 2. So the first thing I'm going to do is cancel those out. That's going to give me 1. Now I have 20 and 4R. What goes into both 20 and 4 evenly? 4 goes into 4 how many times? 4 goes into 20 how many times? So I'm just left with R over 5. Real straightforward, right? Why don't you guys try 9? It's almost the same thing. Try 9. Okay, so what could I cross out? 2p plus 6 and 2p minus 3. They both have what in common? You can just do the 2. You can't do the p because they're being added to something. All right? All right, p minus 3 and 4, that doesn't work. So I'm going to be left with p plus 6 over p minus 3 times p minus 3 over 4 times p minus 3. Now, is there something on the top and bottom that I can cancel out? The p minus 3, right? So I'm just left with p plus 6 over 4. Okay? Why don't you guys try number 11? Try number 11. All right, guys, what could we cross out right away?
Which number?
Number 11. M plus 1, and they both have an 8, right? So I can cross those out too. That means I'm just left with 9 over 7m. Okay, let's try number 13. First, I'm like, okay, I don't see anything I can multiply, but cross out. But now, let me ask you a question. 10v and 30. Is there something that could come out of both 10v and 30 that they have in common? What goes in 10, right? So I'm left with v plus 3. Okay, now I'm going to multiply. 1 times 10v plus 3 is 10 times v plus 3. Okay, and then I've got v plus 10 times v plus 3. Is there something I could cross out now? V plus 3, right? So I'm just left with 10 over v plus 10. So can I cross out those 10s?
Yes.
No, because it's being added to a v.
No.
Okay? It's being added to a v. If it was being multiplied, you could. But when it's being added, you can't. Okay, let's turn it over. Let's trace them on the back. All right, we're looking at number 15. So I know there's a couple things I need to do here. I'm looking at this top part right here. Well, I'm pretty, guys, shh. I'm pretty sure that can be factored. Okay, so I've got a negative 40 over here. I've got x squared here. What two numbers multiply to give us negative 40 that I can add together to give us negative 3? Well, I know 4 and 10 multiply to give me 40, but that's never going to give me 3. 8 and 5, so I'm going to use 8 and 5. Which one should be negative? It's a negative 3, so it should be the bigger number, 8, right? Guys, got to stop talking. You're disrupting other people. So I'm going to be left with x plus 5 and x minus 8. Okay, so that's done. 7 plus 35x. Is there something I can pull out about 7 and 35?
Yes.
What? 7. So I'm left with x plus 5. Oh, well now I see an x plus 5 here and an x plus 5 here, right? Isn't this x minus 8 right here and x minus 8 right underneath it?
Yep.
Cancel those out. So I'm just left with x plus 7 over 7. Don't forget the 7 right here. Okay. All right. 17. I've got 3b squared plus 18b. What could I take out of this? 3 and a b, right? So I'm just left with b plus 3 times what gives me 18? 6. So I can cancel these out. So I'm left with 3b over b plus 8. Okay, why don't you guys try 19? What can I take out of the top and the bottom?
3.
Don't say it out loud. Try it on your own. Try it on your own. There's lots of talking. You guys need to be quiet for other people that are still trying to do it. Okay, we ready?
Yep.
All right. So we're looking at 21x squared minus 21. What can I take out of it? 21x, right? So I'm left with x minus 1. Please don't talk right now. Shh. What can I take out of the bottom? What goes into 18x squared and negative 18x? So first we can take out an 18 and an x. Yes. So I'm left with x minus 1. Shh, you guys. 1, I'm still recording. 2, people are still trying to get this. Okay. Do I agree that I can cancel x squared, x minus 1 on the top and the bottom?
Yeah.
Okay. Let's look over it. What goes into both 21 and 18? 3. So I can change the 21x to just a 7 and the 18x to just the 6, right? Because x and x. All right. 6 and 6, can I cancel those out? Yeah, they're being multiplied. X and x I can cancel, so I have just a 1 on top and just an x on the bottom. Now 7 times 1 is 7. 6 times x is 6x. We're done. Lots of canceling happened there. Okay, I am going to stop it now. We've been doing this for a while. And I'm going to give you guys your homework to work on. But we're going to do more of this tomorrow. Again, do not lose this worksheet.